Just to revisit a couple of old announcements, the quiz that you could use just to prepare for the exam is still on Blackboard. That doesn't have any impact on your grades, so just use it as a learning opportunity. And then homework number 4 is due on Wednesday, so that should be submitted before class on Wednesday. Not listed on the screen here, but just to put it on your radar, next Monday, so a week from today, we'll have our first exam. I'll talk more about that in class on Wednesday and Friday of this week, just to give you a little bit of a heads up of what that's going to look like. But if you want to begin your review now, that's a great idea. So we're going to continue talking about different ways to compare alternatives today with future worth analysis and annual worth analysis. So as we get started on that, are there any questions related to the announcements? All right. Just to review, remember that decision criteria means some sort of a statement or set of rules that you use to make a decision on which alternative should be selected. So when the method being used is present worth analysis, the decision criteria is to discount the cash flows to the present at the minimum attractive rate of return and then choose the alternative that has the highest non-negative present worth. And of course, there are some situations where you'll only have outflows or cost data that's provided and there's no revenue that's mentioned. So as a slightly different implementation of present worth analysis, if there are only costs that are mentioned in the statement and you know that you have to choose one of the alternatives, then what you do is you just pick the option that has the lowest present value of costs. And so minimize expenses is the objective rather than maximizing profits. And remember that in present worth analysis, if we have alternatives that have different useful lives, then there are 3 techniques we've talked about in order to make them so that they cover the same study period. And one approach is the least common multiple approach, which is where you cycle the options to terminate them over the same time horizon. Contract services is where you lengthen the cash flow diagram that's shorter by leasing some sort of substitute or replacement equipment for the intervening years to get you through the rest of the study period. And then early termination is where you take the longer of the 2 cash flow diagrams and make it shorter by selling the item early. And so you're going to be getting more of a salvage value, more of a market value if you sell it before the end of its ordinary useful life. So those are the 3 techniques that we've talked about for present worth analysis. And by the way, present worth and present value are the same thing. Our book talks about present worth. The built-in functions that Excel uses describes that same idea as present value. It just means taking things to time 0 or the present. Now in future worth analysis, we use the same ideas and methods as present worth analysis, except for instead of taking all of the money to time 0, you're going to be finding a single lump sum at some point in the future. The same restrictions apply where you have to compare alternatives, cover the same study period. And so because of that, you'll have to use some of the same techniques that we talked about with present worth analysis. Those same 3 methods can be used if you are comparing alternatives and finding what is their future value. Now you may be wondering, why would you want to find a lump sum future value? Like, what are the situations in which you'd be comparing alternatives and wanting to find, instead of a series of outflows over time, for example, how much should you sell an item for after investing in it for several successive years? So the common applications of future worth analysis are situations like long-term construction projects where investments occur over multiple years. And so think about how long it would take to do the earthwork and paving and buildings for an airport, or building a lengthy toll road where the construction period could spread across many years. Tunnels is another example where the duration of the project could require investments each year or continuously over a period of time, and then the contractor who's built it or the investing conglomerate that came together to make the project would then sell the project all at once for a single lump sum. So that's just an illustration of why you maybe would be tasked to find a single future value as the equivalent economically for the investments over time. Another place where you maybe use future worth analysis is if you're going to be selling something before its useful life is over. So these two illustrations, option A and option B, you couldn't compare them directly because option A, the one on top, covers a 4-year time horizon, and option B, the one underneath, covers a 5-year time horizon. So we would need to either use least common multiples, contract services, or early termination to make them cover the same study period before we could compare them. So the decision criteria that we use in future worth analysis is very similar to what we did with present worth analysis. Instead of discounting outflows and inflows to the present, we're compounding them at some interest rate, the minimum attractive rate of return that's defined either by policy or by your borrowing costs, or it's just given the interest rate. And then the way that you know which option to choose is you choose the alternative with the highest non-negative future worth. Or in the case of cost-only alternatives, you would minimize costs. So you choose the option that is the least costly, that has the same utility, able to generate the same revenues. Now, annual worth analysis is a little bit different because we don't have to apply the same techniques to make different options last the same duration if we're comparing them on the basis of annual worth. Because annual worth analysis automatically assumes repeatability. So if you have two options and you just find out how much they would cost on an annual basis, then you can compare them directly without having to apply LCM, contract services, or early termination. So what annual worth analysis does is it says, take any amount that isn't already in an annual basis and convert it to a series of equal annual amounts that is economically equivalent. So you'll see in this cash flow diagram, what it looks like is that we've got some piece of equipment that we pay a lump sum for at time 0, and then probably during the first year, some sort of a refurbishment or repair is being done, and so the extra 5, let's say it's million, is payable at the end of the first year. And then there's a series of arrows that's equal in length and amount. That uniform series means that each year there's probably some sort of an operations and maintenance expense. And then at the end of the useful life, this piece of equipment is sold for scrap and it has a single lump sum salvage value. So in the case of annual worth analysis, is you're taking alternatives and you're just finding out how much would they cost on a single annual worth basis, so that you're spreading out over time all of the costs and inflows. So for example, what that means is this annual series of 0.9, that's already in the annual terms. So we don't have to do any conversion with that. But the salvage value that's in year 8, you'd need to do find A given F to spread out the single lump sum over the annual series. Likewise, this single lump sum in year 1, what would be the strategy we would have to apply to find the annual equivalent of this amount, which is in year 1? It would be 2 steps.
Future value?
We could move it to the future. That would be one option, is take it from year 1 to year 8, and then from year 8, spread it out over the rest of the years. And so we would do, for example, find F given P, N equals 7 to get it to year 8. And then we'd say find A given F, N equals 8.
Could we also add it to present worth and then find A given P?
Pretty close. I wouldn't say that we'd add it. I'd say we'd move it to time 0, and that's probably what you meant. is we would do find P given F, we'd take it to year 0 and combine it with the amount that's already there. So that combined amount from year 1, which has been moved to the present, we would combine with the amount that's already at year 0, and then find A given P. All right, so that's annual worth analysis. And remember, the big asterisk, what you should be writing in the notes about annual worth analysis is once you've calculated the annual worth of things, then there's no further need to change the time period over which the cash flow diagram covers. So if you've got one option that lasts for 3 years and another one lasts for 7, once you found the annual worth, then you can compare them directly because it automatically assumes repeatability. So there's no need to do LCM if you're comparing options by annual worth. Any questions about that? All right. So the decision criteria in the case of annual worth analysis is that when all of the cash flows are expressed on an annual basis using the minimum attractive rate of return, so we may be compounding things into the future, we may be discounting them backwards in time to the present or to an annual series. When all those cash flows are expressed on an annual basis, choose the alternative that has the highest non-negative annual worth. Or in the case of only costs, choose the one that has the lowest annual worth of costs. All right, so now in the previous classes we've talked about present worth analysis. Today we've talked about future worth analysis and annual worth analysis. There's one kind of tangent that's related to annual worth analysis that we'll be talking about today that's called capital recovery. And as in the case of just annual worth analysis by itself, capital recovery has the same advantage that you can compare items that have different useful lives. So it's a little bit simpler if you already know you're going to be repeatedly buying things, use its entire duration, and buy it again through a certain number of cycles. Then annual worth analysis will allow you to do that without having to manually make the adjustment by finding the least common multiple term. But in order to be able to solve with annual worth analysis, you have to at least have services needed for the LCM of the two options that would have been calculated if you're comparing something, for example, that's 3 years and 7 years, the LCM of 21, you're going to have to repurchase the item that is a 3-year duration several times to make it through the LCM. So you wouldn't compare the alternatives if you were only going to keep them for 10 years, for example. You wouldn't be able to use annual worth analysis in that case. And if you are using annual worth analysis for comparison, then the option you choose will be repeated. That's the assumption that's built in there. And then the same thing that applies anytime we repeat alternatives is that we assume the cash flows will either be the same or that we're able to adjust for the inflation or deflation rate in the repeatability. All right, so here's what capital recovery looks like. This phrase capital recovery is something that's really important for you to be able to explain. We'll have some short answer and concept related questions on the exam. And I haven't written the exam yet, but I do frequently ask people to explain capital recovery. So what it is it's a certain amount of money you should make in order to cover the equipment costs. It doesn't include the maintenance or operation or fuel costs. It's just the cost of acquiring the equipment, meaning the annual difference between the initial acquisition at the present and the salvage value. So capital recovery says find A given P for the purchase price, and you find some annual series, and then you find A given F with the disposal value, and you find the combined amount. That's the capital recovery. That's how much new revenue you'd have to generate in order to balance out the cost of owning the equipment. So if you buy a car, hold it and use it for a certain number of years, and then you sell it, you could calculate on an annual basis, taking interest rates into account. Now keep in mind, this isn't just, for example, taking the purchase price and dividing by 7. That's not how economic equivalence works. Economic equivalence takes into account the time value of money, and so you're finding the annual equivalent of this initial purchase price, where you're spreading that purchase price out over time and compounding at the interest rate I that's defined. And then the same thing is true with the salvage value. You're not just dividing by 7, you're finding the economically equivalent annual series that relates to that salvage value. Okay, we'll revisit this notion of capital recovery in class on Wednesday, but I wanted to introduce it today, just so that it starts to percolate through your mind. All right, let me hand out today's in-class exercise. We're going to use future worth analysis to compare two options that have to do with a shipping channel. Now this one, future worth analysis, you will have to use LCM. So it says that in the problem statement to use least common multiple and future worth analysis to determine which option is better. As there are extras, pass them backwards, please. Now we're going to use Excel for this one, so feel free to start up your spreadsheet. I'll take the extras. Thank you very much. I think there are a couple of people who came into class late today. Let me bring up the QR code so you can get late credit for attendance. Oh, that's today. Are there any extra handouts that weren't used? Yeah. Remember that in the case of future worth analysis, you need to have a reverse time column. So you're going to have years and then years until year 9 in this problem. So my suggestion is write the repeated cash flow diagram right on the paper. For option B, you're going to have to go through a couple of cycles. Sketch that out on the paper and then translate the cash flow diagram from the paper to the spreadsheet.
Can I also make a mention of, instead of having a reverse years column, you can also build the reverse years into the future value formula, where instead of n being just the value in the years column, n can be total years minus the value in the years column.
That's true. Yeah, you can put the equation in the formula. What I found is that that leads to more mistakes, but if you've got an eye for detail, then go for it, by all means. If you're not sure how to set it up in Excel, I've just kind of outlined a template on the screen here that you would translate the cash flow diagram into the table. And then what we're going to look for is the total.
We don't do that. We don't renew it last year.
Yeah, just because it's just how it is. How about saying, I know we never renewed on last year. My bad, I would have told you this.
ENGR is.
With records, like I don't know like how much I have to explain here. I just said also be better because it yields the lowest negative, highest positive future work value, lowest cost.
Just go.
It's just negative because that's what it is presently.
So when you repeat option B, that means you're gonna pay again in year 3, right? So you have to pay again in year 3. So if you look at year 3, the cash flow diagram, it's negative 190 million because you get the 35 million in revenue, but you're also spending 225 million to do the item again. So you've got both revenue and cost in year 3, then you repeat it again in year 6. But you don't do it in year 9, because if you did it again in year 9, then that would entitle you to another sequence of revenues. And you want the sequence to be finished after 9 years.
The correct value for
Yeah, but I didn't know if you used PB.
I guess it doesn't matter.
We gotta use it.
What I do? These are all the same.
Those. I think you're missing a. That's a 19 million. No. You're still off. You're still off a little bit. I don't know.
It's getting like the opposite bound.
Oh, I'm missing a 35 million.
Because that's how much you pay.
I think so, yes. Probably you put the minus sign. That's what it's. Dollars.
This way, so put the whole amount, the amount has millions.
The thing that would be confusing is if you want to write out your answers.
Okay, so hopefully if you haven't at least finished, you've got the idea of what the cash flow sequence should look like. So you're buying it again in year 3, get a series of revenues, buy it in 6, get a series of revenues, do not buy it again in year 9. Any kind of general high-level questions on this one before we move on? I want to demonstrate the next one. Rather than having you do it, of course you're welcome to if you like, but I think that in the case of this particular example, it would be, we cover more ground more quickly if you just kind of watch how this one can be solved. So the second problem says that your uncle wants to make an investment, is interested in the total value of the investment at the end of an 11-year time frame. There's 2 options. One where you pay $250,000 today and then receive $33,000 each year. Option B returns $25,000 each year, but we don't know the purchase price. So let me show you what the cash flow table would look like for that comparison of alternatives. I'll just create another workbook in here. Okay, so the interest rate that's applicable in this problem is 4.5%. So 0.045. And then we're going to have year. Since this is a future value problem, I think it's useful for us to have years until whatever the specified future value is, which is 11 years. And then we're going to have amount, FV of amount, and then the 2 options that we're comparing, option A and option B. Okay, so translating what it said about the opportunities is that we know the inflow and outflow for one of them, and the other one, we know how much revenue there's going to be, but we don't know how much it's going to cost. And so that's actually what we're going to be solving for, is what should it cost in order to be equal to this option A. So option A was you spend $250,000 and then you receive $33,000 through the 11 years. So here's option A, and if we want to find out the future value of each of these, use the future value function for 4.5% interest. The NPER is the reverse time column, which tells us how many years in the future it needs to be compounded. Double comma to skip over the payment, and each of these individual amounts are going into the present value field. Okay, so that leaf blower adds a nice touch, doesn't it? All right, so we want to find out what is the total value of this opportunity. If we add it all up, if 4.5% is the MAR, then this is worth, in year 11, $51,045.64. So what that means is that in addition to receiving 4.5% interest, this has a net profit in terms of a lump sum amount in year 11 of $51,045.64. So the question is, for option B, how much should you pay to be able to make the same amount? Now what we know about option B is that it has an annual revenue of $25,000. So $25,000 is the annual revenue. Let me just format this as currency now. Okay. but we don't know how much he's going to pay. Just as a starting point, let's say maybe he's going to pay $100,000. So negative 100,000, just as a guess. And we'll find the future value of each of these at 4.5% interest. The N will be the reverse time column, skipping over the payment field so that each of the amounts are in the present value field of the formula. And I've got this negative sign here just because Excel automatically is going to change the sign anytime I use these financial functions. All right, so we found the future value of all these amounts, and one way to check to see if the formula is operating correctly is the last year amount should be the same. So if it is $25,000 in year 11, it should be $25,000 in year 11. So it's not moving any years in this last row. So now we can add it up. Okay, so now here's our objective. In this problem, it's asking how much should you pay so that the total future value is equal to option A. So option A was $51,045. Right now we want to find out how much should you pay. This is the unknown that we're going to be playing around with. We just guessed 100,000. It's not 100,000. That was just taken out of thin air. But we want this to equal 51,045. So if we go to what if analysis, which is on the data tab, goal seek, my goal is for this to equal 51045.64 by changing the cell, which is the purchase price. Click OK. So what that says is the answer, we can pay $181,768.66 in order for option B to have the same overall future worth as option A. So it just tells your uncle how much he should be willing to pay if option A is available and it's already priced. He already knows what's going to be the yield on that. It's going to yield him an extra $51,000. For option B to yield the same amount, this tells him what would be a reasonable purchase price, how much he should pay for option B. Okay, so this is something that you should be able to do using goal seek. So the goal seek, just to revisit that one last time, if we started out with a guess value, let's say, what if you paid $1? If you paid $1 for this, then our goal seek is here on the data tab, what if analysis, goal seek, we want, this is our objective, the total amount should equal 51,045.64 cents by changing the purchase price. And as soon as I click on OK, it's going to start changing the purchase price over and over and over, many, many times until it sees that the target cell, F17, is equal to the objective that I've typed in of 51,045.64 cents. So it's making the changes, and it finally stops at 181,768. All right. So my suggestion, if you didn't follow along and key that in, that's totally fine. But later on today, go through and solve this one. And remember that the recording will have all of my functions and the things that I typed in. That'll be posted on YouTube later today. Let's now move on to annual worth analysis. Okay, the next problem in the handout that I've given you says that we've got a transmitter that costs $8 million now, $5 million to refurbish in year 1, and $0.9 million worth of annual operating expenses are already known, then there's a salvage value of 0.5. So find out what is the annual worth equivalent of this, and I provided the 8% table. So we've already kind of talked about the strategy for this one. Go ahead and execute that strategy. Calculate the net annual worth.
It's like, take what the guy says, line it, and what do I mean by solution study? Kind of a structure of what steps you're gonna take.
Like, this coming back to the present and nationwide anyway.
You don't have to do that.
The table is on the back side of the paper, the 8% table. If you're not sure what I mean by solution strategy, here's what I have as my solution strategy. There's more than one way to solve this problem. This is just how I chose to solve it.
I didn't say anything like that. Actually, I probably did say that. Should be allowed to have a should be allowed to have a vote.
It was funny. Frankie called Millie.
I almost did. I thought it'd be like an hour.
Yeah, literally 59 minutes and 52 seconds.
Well, you know, you got it easily hung up.
At least you were concerned. They are at one. Please call for a little more.
I think so. That's what she sent out at the end of the semester. I haven't read that.
They were just on Fridays and Mondays.
I have to check the syllabus to be sure.
Oh, B, bring it back to zero. So make that a little further.
Okay, I don't think we're going to make it to the fourth problem on the back side of the handout. We'll revisit that on Wednesday. But let me just talk you through how we found the annual worth of this. So the things that aren't at an annual worth already are the initial purchase price, which here I've labeled as A, this refurbishment cost, which is labeled as B, and then the salvage value, which is labeled as C. So my strategy was move the amount from B to A and combine that in the present and then find the annual equivalent of that. And then you can directly find A given F for this amount at C. So the three parts in the end of the answer are the annual value of the salvage, $47,005. The annual value of the purchase and refurbishment cost, and then the $900,000 that was already as an annual amount. All right, that's all the time we have for today. Again, my recommendation is to solve that second problem, get the practice. You need the reps to get good at it. Do it this evening. The video will be posted on YouTube, and let me know if you have any questions.
Go up.